In this video we're going to look at reduction reactions in a base. Remember that basic solutions have high concentration of hydroxide ions. So the one that you're going to have to memorize here is reduction of permanganate. Permanganate is going to oxidize P or D block metals, sulfite ions, and substances that have a lower or less positive oxidation state than usual in basic solutions. So manganese is going to be reduced here from +7 to +4. Now note that the ion is on the product side is different than it was in the acidic solution. It was manganese +2 in the acidic solution. So make sure you know the difference there. So if we have a basic solution containing magnesium sulfite mixed with a solution of potassium permanganate, what are our reactants going to be? Well, we're going to have our permanganate ion and our sulfite ion because our magnesium and our potassium are both going to be soluble with everything. So they're both spectators here. So what are our products going to be? So we know that because this is a basic solution, the permanganate is going to go to MnO2, and we know that the sulfite is going to go to sulfate. So the sulfur's oxidation number is going to increase from +4 to +6. So we have to use our half reaction balancing method to balance this equation. So step number 1, we're going to start with our reduction half reaction. So that's going to be our permanganate going to MnO2. So the second step is to balance all of the atoms except for O and H. Well, our manganese is already balanced here. Step number 3, we're going to balance for oxygen by adding waters. So we need to add 2 waters to our products so that our oxygen's balanced. Now we're going to balance for hydrogen by adding H pluses. So we need to add 4 H pluses to our reactant side. And then we need to add our electrons. So our electrons are going to be added to our reactants here to balance out the charge, as our product side is neutral here. Alright, let's look at our oxidation half reaction. So we have our sulfite going to sulfate. So now balance everything except for O and H. Sulfur's already balanced. Now we're going to balance O by adding waters. So we need to add 1 water here on the reactant side. Now we're going to balance our hydrogen by adding H pluses. So we need to add 2 H pluses to our product side. And now we need to add electrons to balance out charge. So electrons are going to be added to our products here to balance out our charge. Now let's look at our 2 reactions that we have and multiply so that everything cancels. We have 3 electrons on our reactant side, and we have 2 electrons on our product side, so we need to multiply by 2 and 3. And so when we do that, we get these 2 reactions, and you can see that our electrons are now going to cancel. So when we add them together, we get this equation. Now, for basic solutions, there's one more step, because the presence of hydrogen ions means that we have an acidic solution. Now, the question told us that the reaction took place in a basic solution. So we're going to need this one last step. The 2 hydrogen ions and the 2 hydroxide ions need to turn into water molecules. So what we're going to do is add hydroxide to both sides of the equation. Okay? So when we add the 2 hydroxides here, those 2 hydroxides are going to react with the 2 hydrogens, and we're going to end up with waters. So 1 water is going to cancel from each side of the equation, and we are left with our balanced, our redox reaction that's balanced in a basic solution. You can also do titrations with redox. It's often used to determine the concentration of the species that can be oxidized. So we take a solution with a known concentration that is easily reduced and add it to a solution with an unknown concentration that's going to be oxidized. You are going to have a color change to signal the endpoint, and at the equivalence point, equal numbers of moles of the species have been oxidized, and the species being reduced will have combined. So here is a picture of what this might look like. Now in this case, we have potassium permanganate as our titrant, and we're adding that to an iron plus 2 solution of unknown concentration. So the permanganate ion is pink, and the manganese 2 ion is colorless. So as the pink permanganate solution is titrated into the solution containing the iron, the two are going to react to form manganese plus 2, which is colorless. Toward the end of the titration, the titrant is added 1 drop at a time. So after all of the iron 2 ions have been reacted, one final drop of potassium permanganate will turn the entire solution a very light pink, because this drop is going to contain permanganate that has nothing to react with. This is the end point of your titration. So the number of moles of iron 2 present in the original solution can be calculated by multiplying the number of moles of permanganate delivered by 5 here, because that is our mole ratio from our equation.